Hi everyone, my name is Maggie and I will be your host for today's webinar on scheduling for space system operations. Today's presenter is Alex Herz, co-founder of Orbit Logic. Mr. Herz was the original designer of the STK Scheduler app and other Orbit Logic software solutions, and has over 25 years of experience providing planning software solutions to commercial, civil, and DoD space programs.
Thanks, Maggie. So I'm here today, but I also have a technical team with me, including Ella, who's kind of running the presentation. So if any questions come up, I think we have the expertise in the room to get that stuff answered. Okay, so what are we talking about today? So as many of you probably know or are aware, scheduling for space systems can get complicated very quickly. Not only do you have to deal with system models and the system constraints, physical constraints, but also things that are maybe a little more nebulous, like operational constraints or goals, the cost of maybe some of your resources or assets, optimization goals, and things like that. So while you build a system and put it together, it may seem straightforward, and then you get into operations, and planning and scheduling for those operations can get complicated very quickly. So this especially comes up as systems are about to go into operations, and how are you going to use this wonderful system that you've built that may be very expensive or maybe not so expensive, but you know, if you're putting it in space, there's certainly a cost there. And how are you going to use that? And it's often the very last thing people think about. They're worried about the hardware. They're worried about making sure the communications are working. They're worried about all the testing they're doing, the vibe testing, all so it's going to operate in space. And then they get towards operations and they realize, wait, exactly how are we going to operate this thing? And so we have lots of examples of customers that come to us within a year of launch, and they really have not figured out how they're going to operate, or they thought it would be simpler than it was going to be. So we're going to talk about some simple planning tools, which are often the first approach people think of, and then talk about some of their limitations. Okay, so especially with some of the newer systems that have lots of components coupled together, that can sometimes greatly increase the complexity of planning, especially if you have multiple elements on the ground and in space all working together. And often that leads to not only more complex systems, but also a much larger solution space for the scheduling. You have lots of different options of how to approach and complete your mission, and so which one is the best, and that makes scheduling all the more difficult. We also hear a lot of what I call myths of scheduling. We often, right up front, people will tell us, well, we don't really believe any tool could do our mission, that there's no such thing as a configurable generic scheduling tool because my problem is unique. In fact, I have a letter from NASA dated something like 2001 that specifically states they're not accepting our proposal to develop a generic scheduling tool because they don't think it's possible. So that's, you know, some of the myths have built up over the years because maybe software wasn't at the point where it could do some of these things. Other things that we've heard is, well, there's no way to know what the best solution is, or that my planning constraints are too complex to codify, and it really has to be a person that figures out these plans, or I don't trust plans generated by automated algorithms, that they're often wrong or don't consider all the proper constraints. So there's a lot of excuses people use about why they are not using an automated planning tool and why people need to be in the loop. So just some of the things that we're often hearing and having to push back against. Okay, so one of the very common approaches that we've heard from lots of missions, even newer missions, is that their planning, their solution is basically STK and a spreadsheet. That they'll compute things in STK or in other tools, they'll bring that information into a spreadsheet and lay out their plan this way, and essentially build their timeline in a spreadsheet. Some of the things that, some of the limitations of this approach is that if you can't do everything and you have to make decisions, the spreadsheet is not a very good tool to help you do that. So So priority may not be accounted for. How do you handle tasks that can't be scheduled? Like if you go and build this spreadsheet manually, and then where do you put those tasks and how do you keep track of them? There's generally no automated deconfliction unless you're very good with some complex macros, things like that. There's really no plan visualization other than, maybe some charts or graphs that you could build off of the spreadsheet. Dependencies have to be very simplistic. It's difficult to track resource capacity usage, and things in a spreadsheet solution are not easily tied to physical constraints, which can often change. For your orbit changes and some of your tasks and constraints can move around. It's hard to update the spreadsheet. So replanning can be very difficult. We have one customer who's now using some software that we provided them that used to work this way with the spreadsheet, and it literally took them days to replan. So this was a customer that was doing launch planning, so they had pre-launch and launch and early orbit schedules they were working, and whenever they had a launch slip, the planning process was one of the long poles in the tent. It was the critical, it was the critical path to getting, one of the critical paths to getting back on for a new launch was having to replan their whole schedule with the spreadsheet. So it can be very expensive from a time point of view to use this from a replanning perspective. Okay, let's go to the next sheet. The other kind of tool that is maybe one step ahead of a spreadsheet are what we call timeline tools. So these are tools where generally you're doing manual planning, but they're laying things out in more of a graphical form, and they have some amount of constraint checking to them. Some of the difficulties with or limitations of a timeline tool, which can be very good graphically, and so it kind of shows you and it is a good visualization, but again, replanning can be difficult because it's generally manual planning with these tools. There's very limited validation. You write a bunch of rules about this or that, but maybe you don't think of some of the cross relationships which can cause problems. The other major limitation of this kind of tool is that generally the tasks and resources are hard-coded. You have to predefine, here are the things I'm going to do, here are the resources that are going to be used, here's the rules to using or doing this task, and it's all kind of hard-coded, which makes it very difficult to apply to other missions. Generally, these tools don't have a very good way to account for variable duration tasks. And so again, similar to the spreadsheet, you have to compute things outside the tool and then bring them in. There's not a lot of optimization here. You can put together a plan using one of these tools in more of a graphical way, but there's no embedded modeling. There's not really any optimization. And so it has some limitations from that point of view. So we had a customer that had a timeline tool that they had used previously. They really liked it. Their operators were used to it. They were trained with it, and they asked us to update it for a new mission. So right away, we knew that it was definitely the situation where it was difficult to apply to a new mission. They were asking us actually to go into the code and hard code new kinds of tasks, update the rules for their new mission, and it was a lot of work to do this. We got them the tool. They were fairly happy with it because their operators were used to it, but there was a better way to do it. Another option, of course, is a custom tool. So especially if a program or certain managers or whoever think that a generic tool is not going to meet their needs and they want something more sophisticated than like a spreadsheet or a timeline tool, you can, of course, go from scratch to develop a new tool specific to your mission. Some of the problems with this is that it can be expensive and risky to develop these tools, especially if it's maybe the first time you've done this. There's cost risk, there's schedule risk, there's technical risk. We've had situations where people come to us for a solution off the shelf because on their particular mission, they were developing their own tool. It wasn't going to be ready in time for launch, and so they needed something, quote, in the interim until their tool was ready. And so they came to us for a solution like that. Another problem with these kinds of custom tools is that feature gaps are common. So we've seen multiple situations where they said, well, we developed this tool and we were going to use it for planning, But then we got into operations and we realized that it was missing some things, and so we have to do some, they weren't using it the way they had hoped. It wasn't really automated planning. There was a lot of manual intervention because of feature gaps. Another thing about custom tools is even if you're willing to spend the money up front to develop them and you meet all your costs and schedule and technical risks and you don't have any feature gaps, that's great. You've done a great job developing your custom tool. The problem is it's a custom tool and no one else knows how to maintain it. So you have to pay people to be around to maintain the tool and fix bugs and things like that. So they can be extremely expensive to maintain, especially compared to off-the-shelf tools. The other thing with custom tools is that, again, similar to timeline tools, they can be difficult to adapt to changing requirements or constraints. There's coding to be done because they weren't originally designed for kind of a big problem set. They were designed for a specific problem, and when that problem changes, there's coding that has to be redone. And thus, the last bullet, which makes them difficult to reuse for new missions, because often those missions have slightly different requirements, and now you're back into coding again. Okay, so just to kind of go over some of the cost of approaches with the tools that we've talked about, with the timeline tools and the spreadsheets, you're doing a lot of manual planning, which really you could potentially miss opportunities because it takes so long to do your planning. We've had conversations with customers that have literally built their concept of operations around the fact that it takes them 4 hours to develop a plan for 24 hours. And so it affects everything of the mission. And there's very limited capability to react dynamically to situations because the planning takes so long. The other issue with manual planning is that you have increased risk. So because there's limited validation in some of these other approaches, you can have situations where, yes, you've put together a good plan, it all makes sense, but somebody somewhere missed some kind of physical constraint violation because there wasn't the kind of checking that you might need for an operational mission. And so you create a plan, it looks good, it gets sent up, and then you lose part of the mission because of it. You missed an opportunity or something. And of course, taking longer means you're spending money on personnel to do mission planning, which that money might be better spent elsewhere to have people doing things that you couldn't use a software tool for. And now that said, with the custom tools, in theory, you have automated planning, you have all the features that you would want, and that's great. But the issue there for cost is the maintenance expense. It's expensive to keep the developers around to continue to maintain that tool as your mission goes on. One of the other things about some of these other tools and approaches like spreadsheets and timelines and things like that is they can work well for relatively simple missions, but as missions get bigger and more complex, it turns into a situation where a human just can't do it. So let's go on. We have a couple of examples of that. So we had a customer come to us a few years ago with a Constellation design. It was a large comm constellation, literally hundreds of satellites, dozens of ground stations with multiple antennas at each ground station. And they needed to plan communication contacts between the ground and the satellites to keep persistent, continuous communication from all satellites to some ground segment at all times around the entire Earth, with, of course, the need to have for deconfliction and efficiency. So you can't have an antenna looking at two satellites at the same time. So how do you decide which ones to go? So it's a very large problem. And STK is very good at computing all the contact opportunities, but wouldn't it be great if you could extend that to actually resolve conflicts, adhere to priorities, and actually make decisions on how to optimize the resource usage? So kind of extending those STK computations towards operations to actually execute that mission. Okay, another use case that we have is space situational awareness. So this is where you are observing objects in space from sensors. And as an example problem that we've been running recently for some government customers, let's say you have about 50 sensors and you have about 15,000 space objects in the current public catalog. And on average, say you have about 3 observation opportunities per day from each sensor to each object. That's a big problem. So how do you solve that problem? So you have to have planning algorithms to solve these kinds of problems, whether it's the Constellation context scheduling problem, or it's the problem of space situational awareness, looking at lots of objects. It's too big for a human to calculate. Even if a human could possibly keep up and make all the decisions, there's certainly not going to be any optimization in there. It's just too much. So like as an example, even I guess kind of a third example is when imaging satellites became more agile. Instead of just collecting a dozen or so images per orbit, they're collecting hundreds of images per orbit. Again, a human cannot keep up with that, even if there was only one satellite. But of course, there's way more than one satellite now in these constellations. So it's just too big a problem. You have to have automated planning algorithms. And it's not just about computing the opportunities, which of course have to take into account all the constraints, which is like STK is very good at, but decisions need to be made. You have to execute your mission based on that information, and that's where the planning software comes in and the algorithms come in. Okay, so I think at this point we want to throw out the question of to the participants, the audience, like what kind of features, if you wanted to say one feature you would like in a planning system, what would it be? And you can kind of think about that and answer that question. And you don't have to come up with all of the requirements for a planning system, but what's kind of a key feature that you would like? Obviously, we're going to talk a little bit about STK Scheduler here and how it solves some of the problems of the other approaches that people have used. And this is one screenshot of STK Scheduler. It's a good display to show the task that you're trying to accomplish, the resources being used, the opportunities, which we call time slots, resource availability, things like that, and details about the task. So you get a good this is one of the overviews of the schedule solution, and we're going to go talk in about some of the detailed features. But overall, STK Scheduler is software designed specifically for activity scheduling and resource assignment and deconfliction to generate optimized schedules. So some of the key features of STK Scheduler are robust and flexible task specification. And again, we're going to cover each more of these bullets in a lot of detail as we get to the specific slides about them. Flexible resource definition, so you can define basically any kind of task. You can define any kind of resource with their generic attributes, and we'll get into more detail about that. It obviously offers schedule optimization and deconfliction. You'd be surprised how many people ask me if the schedules generated by STK Scheduler are deconflicted, and the answer is yes, absolutely. Manual and automated planning. So while we provide automated algorithms, you can do planning manually and make adjustments manually, and we'll talk more about that. Automation and integration. We have a great API and comprehensive API with STK Scheduler, very similar to STK's interface that allows you to integrate with third-party applications. And one of the really powerful features of the software is a seamless interface with STK, so you can take advantage of all the things that STK can do, including, for instance, relay communications with MEO satellites, as an example, to answer one person's question. And the software can be applied to any mission phase or any type of mission, and in fact, it can be applied to non-space missions as well. So it's very flexible from that point of view. From a high-level ops concept point of view, how do you use the software? Generally, the first thing you're going to do with the software is define your model, essentially define your resources and their attributes, whether those are satellites, ground stations, antennas, recorders, things like that. So defining your model, defining your resources and their attributes is the first thing that's done, essentially configuring the software for your particular system. Then defining the tasks. What are you going to do with your system? Are you going to be imaging things? Are you going to be communicating? Are you going to be collecting science? What are all the things that you need to do as part of your mission? Those are the tasks, what we call tasks. Tasks have constraints and resource needs. So those are defined as part of the task definition. I can only do this during the day, or when this object is in sunlight, or I can only do this when I'm above, 20 degrees above the horizon, or I need 2 ground station communications simultaneously from this MEO satellite or something, whatever. All those kinds of things are defined as a task, and we'll talk more about that. The algorithms, after you've defined your resources and configured that, after you've defined all your tasks, you specify a period of time and you run the algorithms to find a deconflicted optimized schedule solution. Actually, you can define multiple solutions. The operator can then review the solution and make any manual changes. That review and manual changes, that's entirely optional. You can run lights out if you want to, but there are Gantt and table and STK 3D visualization views that you can all use to understand the schedule solution that's generated. The software does provide a tool for validation of any manual changes, and we'll talk more about that in a little bit. But in general, you model your system, you define what you want to do, you use the algorithms to find solutions, and then you have the solution to review or use to execute your mission. So resources. Let's go into a little more detail about resources. What are resources? They are things you need to use to accomplish your mission, whether it's a satellite or a recorder or a person or a piece of equipment. The resources in STK Scheduler are set up with generic resource attributes. All resources can have a setup and or breakdown time defined. How long does it take to configure the resources to execute a task? How long does it take to reconfigure it afterwards? Resource availability and blackout schedules. Like, if I don't have full control over the availability of that resource, when is it available to me to use? Or when is it down for maintenance, or whatever, things like that can all be defined. Resources can have priority, which is sometimes referred to as resource preference or desirability, but that's a generic attribute of any resource in case you prefer to use and to write a report versus Bob or something. You can specify that kind of resource priority. You can associate resources with STK objects. So resources in STK Scheduler can be anything. If they happen to be something that's associated directly with an object in an STK scenario, you can make and define that relationship, which provides a lot of good shortcuts when we get to defining tasks that require multiple resources, and we'll talk about that when we get to the task portion. Resources can have configurable capacity definitions. So for instance, a recorder has a certain capacity. A bandwidth on a data link has a certain bandwidth limitation. Your gas tank can hold so much gas. So those are the kind of resources that have capacity. Not all resources will have capacity defined. The other thing that we talk about that's not listed here is accommodation. How many tasks can the resource support simultaneously? In some cases, it might be unlimited. In some cases, the default is one thing at a time for a resource. So, and there's no limit on the number or type of resources. Resources can be anything. So one of the examples I like to use is if you're defining a ground station as a resource and you're only ever going to use that ground station, let's say it has one antenna, you're only going to ever use it to support one task at a time, define the whole ground station as one resource. If that's the scheduling level, that's fine. But what if you had a ground station which had 2 antennas and 3 different equipment racks and multiple boxes in each rack, and depending on the task you're supporting, you're going to use different racks and boxes in it and one of the 2 antennas, then you need to break down your resource definitions in STK Scheduler to all those individual things, antennas, racks, or boxes in the racks. And there's no limit there. And you can really define anything as a resource. We're not making any hard-coded assumptions about what a resource is. You can define a resource called pencil. You can give it 10 hours of writing capacity. And then anytime you do a task, depending on the task duration, you'll deplete that capacity until you've used it for 10 hours. And then the lead is gone and you can't use that pencil anymore. So really, we're making absolutely no assumptions about what the resources are. And these generic attributes we have found are very good at being able to kind of define the capabilities or the attributes of almost any kind of resource, whether it's a person, a piece of equipment, or a system. So task specification. So again, similar to resources, I'll start with the last bullet. There is no limit to the number of type of tasks you can define in STK Scheduler. All tasks can be defined by the generic attributes. Tasks can be single instance or recurring. They can be of fixed or variable duration, and we have all kinds of options for the variable duration. Can they be broken into pieces? Can you have a 5-hour duration? What's the minimum segment that you can do? Does there have to be handover or overlap, or can you have gaps between the assignments? So all kinds of variable duration options. There are task priorities, and the priorities for tasks, similar to the priorities for resources, are configurable. You have configurable ranges and conventions. So it can be 1 to 100, with 100 being the most important. It could be 5 to 8, with 5 being the most important. So whether you go up or down and how big the range, it doesn't matter. Tasks can be defined with dependencies on other tasks. So predecessor dependencies, during dependencies, things like that. And one of the most important things about task definitions in STK Scheduler is the task-specific resource requirements. Which resources do I have to accomplish this task? And probably even more important for larger complex problems, what resource options do I have? And so you have formulas that you can define. I need resource A and B and parentheses C or D. And so you can get complex logical formulas there specifying your resource requirements and options for a task. Configurable resource capacity usage. So a task is using a resource that has capacity applicable. Is it depleting that capacity? Is it replenishing that capacity? Is it doing it at a certain rate? Is it using a fixed value? All that is definable within the task definition and how it's going to use each of the resources that it could potentially use to accomplish the task. And back again to, there really is no limit to the number and type of tasks. So you can define tasks as like a ground station contact. You could also define a task as a soccer game, and the resources are the referee and the 2 teams and a ball and a field. So really there are no limits, and it's very configurable to support almost any kind of mission. And I think we have a question coming in.
We have 2 questions that I think now would be a good time for you to answer. One of them is it possible to apply constraints for solar phase angle for observing the scheduling process?
Yes. So and we'll get to that when we get to the STK interface, but as part of a task, you can specify anything that can be computed in STK can be applied as a constraint to scheduling a task or making a resource available for a task. So solar phase angle, you can get a report, you can specify the range limits, what solar range angle range you want, min and max, and then the task will have to be done during that period. And anytime the orbit changes or the schedule period changes, a new report will be automatically requested from STK as long as you define that as a constraint on your task. So that's that one.
Okay. Another question is optimize mission from order deck through reception with multiple sensors, satellites, ground station, and processing nodes.
Yes. So let me just say yes. So if you have, for instance, a task to collect an image and then downlink that image to the ground and then process that image at a ground node and then transfer that data somewhere, all those can be tasks that are defined, and they can be linked as a set of tasks that need to be done. And you can track that for as many targets as you want.
Okay, a couple more questions are coming in. Can this be used to schedule a telescope for optical tracking of geo satellites?
Yes, absolutely. In fact, we've delivered this solution that's based on Scheduler to do both ground radar and optical observations of satellites in orbit in any orbit, including geo.
And talk about the laser communications as well.
Oh, yeah.
Not exactly geo.
Yeah. So we've also applied this solution to laser communication, where you have a ground telescope looking at a satellite that's communicating or downlinking data via laser. We take into account cloud cover and all those kinds of things. So yeah, absolutely.
And then somebody asked, can you expand on the task dependencies with an example, if possible?
Yeah, well, I think we just a little bit talked about one where, for instance, you might have a task to take an image of something or collect some data, and then you have another task to downlink that data to a ground station, and you make essentially the downlink task dependent on the first task happening. And so task B depends on task A to be complete, and you can specify things like the minimum and maximum time from task start or task stop that the second task is related to the first task. So there's a lot of configurability for dependencies in Scheduler.
Okay, and we're starting to get some questions about optimization, so we're going to move on to further in the presentation. We'll talk a little bit more about how optimization works.
Yep. And right here we go. Okay, so STK Scheduler doesn't assume that there's one algorithm that's going to solve everyone's problem well. So we actually provide what I call a stable of algorithms. There's greedy algorithms, there's neural algorithms, squeaky wheel, there's random algorithms. There's a bunch of different algorithms that are provided standard with the solution. And they all provide automated schedule deconfliction, and they all approach optimization in a different way using a configurable figure of merit. So you select from the multiple algorithms, you run the solution, and you look at the solution, but the solution is optimized based on this figure of merit that lets you specify specific goals. For instance, is it more important to get the high priority task done, or is it more important to get more tasks done, or is it more preferred to get tasks done with their desired resources, things like that. So there's a bunch of different optimization factors, and you can adjust the weighting value of each one. Other things that we often get asked is, well, what if I have my own algorithm? Can I plug in an algorithm? And the answer is yes. So all of the information that is available and that we're sending to the internal algorithms in STK Scheduler is available through the API. You can take all of that information, run it through your own algorithm, and send it back in, the solution back into Scheduler for display and analysis and 3D visualization and all that kind of good stuff, and kind of compare it against the algorithms that come with the software. The other thing that I'll say about algorithms is that we, a few years ago, added what we call the Algorithm Builder tool that lets you essentially see into the guts of the algorithms that are provided and make adjustments. So you can actually build or customize or tweak some of the algorithms that come with the tool by making adjustments within the Algorithm Builder tool, saving that as a custom algorithm. You can save as many custom algorithms as you want, and then run that algorithm, select it when you're going. The other thing you can do with the Algorithm Builder tool is essentially build an algorithm of algorithms where you're essentially running all of the different algorithms and comparing the results and taking the highest scoring solution. Several of the algorithms have random seeds, like the neural algorithm and the random algorithm. And for those algorithms, you can specify the number of runs that you want to make for optimization purposes. So you can run the random algorithm, choose the random algorithm, and specify to run it 500 times or 1,000 times. It's going to run it that many times with that many random seeds. All of those solutions are going to be scored using the figure of merit, and the highest scoring solution is going to be returned for assessment by the operator. What the other thing I will say in general about the algorithms is that the algorithms are more numerical based. They're not rule-based algorithms. So some of the systems that we come up against out there being used that often have difficulties handling changing requirements are rule-based systems where the rules have to all be rewritten if something changes about the mission. So we model the problem differently. So it's essentially resource objects and time that's being manipulated. It's not a set of rules that are being run through about, oh, always assign this first and then do this and then do this. Well, we could often box you into a corner. So any new questions about optimization?
Yeah, we have a couple different questions about, I feel like they're questions about what we mean by optimization. So one of the questions is, for geosatellite tracking, can we optimize the scheduler to maximize the number of satellites tracked over a fixed observation period?
Yes. In fact, I would say that that just kind of falls out of the algorithm. So the algorithms are trying to maximize the figure of merit. By getting more tasks done, you're going to generally lead to that, unless you have a really big priority range, like unless some objects are really way more important than others, which would tend to make the system want to observe those a lot. If you put in a bunch of targets, all of the algorithms are going to try to get as much done as possible. And so it's certainly going to maximize that, especially if they're all of equal priority. If there are certain objects that by observing them, you have a high cost for going there, not cost as in money, but cost as in it makes you give up a bunch of other objects, those solutions are not going to win out when you're making your algorithm runs with almost any of the algorithms in STK Scheduler.
The other one that's also about optimization is regarding scheduling data downlink for Earth observation constellations and command delivery to them by using MEO relay satellite constellations. Can we use STK Scheduler to design the optimal MEO relay constellation to reduce the overall system response time to specific EO constellation?
Yeah, so if we're talking about designing the MEO constellation, so I will say this, that you can certainly use STK Scheduler to help model any system you design. So if you have 3 different options for your MEO constellation, you can set up the problem using each one of those different constellations and run the solutions and see which one is best. Scheduler is not a design optimization tool, but it is very good at assessing any design that you specify for it.
Okay.
Should we go on?
We'll go on.
Okay.
These are good questions.
Okay, manual planning. So people have a hard time giving up manual control, and that's totally understandable. There are some things that people are good at. And so STK Scheduler, when it first came out back in 2001, yeah, 2001, so 18 years ago now, was the first version of STK Scheduler, and it had no automated planning algorithms. It was entirely a manual scheduler. Very quickly, we came out with the version with the automated planning, with the algorithms in it, but we've never gotten away from the capability to go in and manually override, manually schedule. If you want to use schedule to do this, you can have it generate all the time slots, not run the algorithms, and you can manually go in and make all the assignments, and it will check all the rules and make sure you've not broken anything. More typical with our customers is that the algorithms are run, the schedule solution is assessed, and an operator, for whatever reason, wants to make a tweak or change a resource assignment or something like that. And the software absolutely allows you to do that. So you can make those adjustments. You can also manually influence what the algorithms are going to do by manually scheduling certain tasks or adjusting certain tasks and doing what we call locking them in so that they cannot be adjusted by the algorithms. And then you run the algorithms and they have to respect those locked tasks and plan around them. So there are some lock and also similarly defer where you're ignoring a task controls that allow you to have manual influence over the algorithm solutions. And the way that you make those adjustments, there's a few ways. You can actually go into the task assignment editor that's shown here and select the specific resource string that you want to use, and then go in and edit the assign start and stops and things like that. But you can also go to the Gantt view and do a drag and drop or drag the duration of the task to adjust the duration. So those kinds of adjustments through a graphical interface are also supported. The other thing is similar to manual planning is that there's this command file import and execution. So you can actually essentially write a script of things that you want scheduler to do in the API command format and save those files and then ingest them at any point, whether before or after you've run the algorithms to make adjustments and things like that. So as an example, you could possibly have a situation where you want to define an ingest file that specifies and locks in certain assignments and then run the algorithms. Good manual capabilities there.
And I don't think you can emphasize enough how important it is to have validation with these manual changes.
Yeah, so So from very early on with STK Scheduler, we developed, in order to test and validate the initial early algorithms, we developed a validation tool that was entirely independent of the algorithms, and it would essentially check a schedule solution to be sure that none of the defined task constraints or resource limitations were violated by the schedule solution. And as I said, that was developed to validate the initial algorithms for STK Scheduler, and then we realized it was an extremely useful tool to validate manual changes, and so we left it in. And it exists today and can be automatically run or run upon request, depending on the configuration.
So there was a question that came up, is the solution dynamic? By assuming there is a change in the operational availability, so one observatory is, say, covered by clouds, can the schedule be automatically modified, or do we need to rerun the process?
So you do need, well, it depends what you mean by automatically modified. So if I have modeled my system and built the schedule for the next 24 hours, and then the weather changes such that a telescope is going to become unavailable. So this is a great example. We've done a tool recently which monitors weather and generates in Scheduler blackout periods for resources based on weather issues, and then the schedule can be rerun. But whenever you change, Scheduler is a batch scheduler. It runs very quickly, but you set up all the information up front, you give it all the information, you run the solution, now you have a solution. If you get new information, you put that into Scheduler and then rerun. And it will adjust the schedule accordingly to account for that new information.
Do you want to
and
talk
you can
to
do that. You can do that quickly.
Yeah, talk to about the speed of that.
Yeah. So that can be done. Generally, I mean, the performance of the algorithms, how long it takes to come up with a solution to the problem, varies depending on the number of tasks, the number of resources, the schedule duration, the complexity of the dependencies, things like that. Lots of factors. But in general, we see solutions coming up very quickly, even for large problems. As an example, we were doing a sample problem showing the space surveillance network and the whole catalog, and we were coming up with a 24-hour schedule for dozens of sensors and thousands of objects in about 90 seconds. And so that is a bigger problem, but it's an example of the algorithm. Okay, automation. Okay, so we talked a little bit about this already, but STK Scheduler does have a comprehensive API. So the API commands are in the STK Connect command format. You can interface with the Scheduler API via COM or TCP/IP, so it can be cross-platform. All of the commands are fully described in the help. You get the name of the command, you get a description of it, you get sample strings to show you, you get a description of all the parameters in the command, and we even provide a sample code for interfacing with the Scheduler API as part of the delivered software. So you have a good jump start to integrating the software. And it is comprehensive, and what I mean by that is pretty much anything you can do via the UI, you can do via Connect command. And in fact, there are things you can do via API command that you can't do through the UI. So it is a comprehensive API that allows you to fully integrate it. You can also run STK Scheduler in the background as a service so that you don't even see the GUI. And it's just running there as a scheduling engine that your application is interfacing with, and you can use your own user interface if you want to.
And we have built custom web user interfaces. We've built custom
and we've had customers wrap our solution in their own UI, and that's fine. Okay. Again, we've covered this a little bit already, but anything you can compute in STK can be brought in as a scheduling constraint in STK Scheduler without you having to write any new code. So if you want to apply a sun constraint or an as-L constraint or a range constraint or something like that to any of the tasks that you're defining or the availability of a resource, you can do that just by simply selecting the STK report, selecting the ranges that applies, selecting when to apply that constraint. and it'll get applied to that task or to the resource availability. So as an example, in the tutorial for STK Scheduler, we have an example of a task that's kicked off within 5 minutes of apogee, every orbit for a certain task. And we just do that by selecting the apogee report, setting the offset time, and now we know when the task is going to start. So very easy to do, no coding, and even if it's a custom report, you can specify custom, you put in the name, a custom STK report, you specify the name of the custom report, you specify the column where the data is, you specify how it should be applied, and that's all done through the scheduler user interface or via API command. The other thing that you can do is associate objects in STK Scheduler with STK objects. So when you define a resource in STK Scheduler and you associate it with an STK object, let's say a satellite, let's say you do that with a satellite resource and a ground station resource. And then you define a task that uses that requires that satellite and that ground station. By default, valid constrained access based on the STK scenario is required between those two objects to accomplish the task. And so that will be one of the constraints that's automatically put on there for you. When you define a schedule, you associate it with a specific STK scenario, so it knows where to go get the data from STK. And then after you're done building your schedule, you can output that schedule for 3D visualization in STK. Here's an example of that from a mission we worked. And it's not showing just the access times between the two STK objects. It's showing the line between those objects or turning on the sensor when that resource or those resources are being used to execute the task. And so you get a list of tasks up on the left, and it dynamically changes, obviously, as it goes through time, based on the schedule solution from STK Scheduler.
We had a question that's not just about STK and that integration, but it is about other physical constraints. Is it possible to apply weather constraints? Only if there are no clouds can you perform your tasks?
Yeah, you can do that, but you have to have a source for that cloud data, and then you have to bring it into Scheduler somehow. So as an example I pointed out earlier, we have a program where we delivered a solution where we were bringing in the cloud forecast from NOAA. We were bringing the free cloud forecast from NOAA. We were assessing how cloudy it was at certain ground site locations that were part of our mission system. And when they crossed a certain threshold, that would trigger us to create a blackout window for that sensor. And we would send that blackout window into STK Scheduler through its API and then rerun the schedule to account for that blackout of that sensor. So that's like one example. So yes, you can certainly do that, but it doesn't come native. Like you have to actually write a piece of code that interprets that cloud data or any external data like that and converts it into something that will affect the schedule in STK Scheduler using the Scheduler API. All right. We often are asked by people, well, is this just for LEO, or can I use it for GEO, or what if I have a HEO or interplanetary? It doesn't matter to Scheduler what the orbit regime is, or even if it is an orbit. And so if you have a trajectory that can be defined in STK, then you can support planning for your mission in STK Scheduler. It's not even required that your mission even be in space. So you could have ground objects and air objects and sea objects in STK, and you can use relationships between those objects and visibilities and availabilities and things like that to define a schedule and use STK Scheduler for it. All scheduling in STK Scheduler is done to millisecond fidelity. That said, there's no limit or constraint on whether or not, or if I'm doing a 1-day plan or a 30-day plan or a 1-year plan, you can define your schedule duration however long you want. And we even support some programs, as I said earlier, they were doing the scheduling of their pre-launch activities before they even got off the ground with STK Scheduler. They were defining all of their ground resources, all of the activities that had to happen before launch were being scheduled using Scheduler, and then, of course, the schedule went seamlessly into launch. They put in the trajectory, and then they had all the launch activities and early orbit activities as well. So really any mission phase. And any kind of mission as far as single satellite, multi-satellite, even large constellations are, it's very scalable. So it easily supports nearly any kind of mission. One of the things that we have like as an extension to STK Scheduler is STK Scheduler Online. So STK Scheduler runs on a server or a desktop and is generally used that way, which makes it maybe not so easy to share your schedules with a large distributed team. And so we developed STK Scheduler Online, which is a web server. You load your schedules onto that server. And maybe one thing I should say is that the schedule solution, or when you're defining a schedule, your tasks, your resources, and even the schedule solution and all of your constraints, when you can save that as a schedule file, an SSC file, I think we call it, and that is saved as a single file. And so that file can be loaded onto the Scheduler Online web server, and then users who are authorized to log in can log into that server, select the schedule they want to view, and they have full access to all the details of the schedule, the tasks, the Gantt view, but then the details of the task, what resources are assigned, the details of the resources, anything available through the Scheduler UI is available through Scheduler Online for viewing by your team. Then the question you should think about is when you come up to a new program or new mission and you need scheduling, how can Scheduler solve your scheduling challenge? And I will say that how you model your system as tasks and resources and constraints and things like that can be an art. Like there's often different ways that you can model your system, and we're always here to assist with that process.
So there's a couple more questions. I think we've answered almost everything. Here's one. If a schedule has been manually modified but needs to be rerun due to new events, does the manual modification remain if they are not linked directly to the event updated?
So that's a great question. So if you want certain tasks to be protected when you manually rerun the algorithms, then you should lock them. So we do have a way to protect specific tasks, and you can protect them by specific, individual task selection. You can select them based on priority range. You can select them based on time period. So you can say anything before this time, lock it, because I can't make updates that quickly, or anything above this priority range, I don't want to touch. So you can make all those kinds of locking selections before you run the algorithms. If you don't lock everything, everything is fair game to be rescheduled.
There are several different questions about output and reports and integration with other parts of the system. That I think we covered a lot of that in the slide on integration.
Well, everything is available. Like when you have a schedule solution, all of that information is available via the API. So you can get that data out and send it to whatever other application you want, or any other application could go in and pull it via the API as needed. And we, in fact, just recently made that more configurable, so you can select specific information from about a resource or a task instead of having to get the whole report. So we made it even easier recently with some of the latest API features.
Yeah, we have one other question that came up that's interesting. Cool. The question is, once we have the schedule in terms of allocated time slot, can we also specify different operations to obtain an output file that can be run on an observatory? For example, CCD exposures create a sort of orchestrated file to obtain SPLU to RA and coordinates for the telescope, and then take several exposures for the CCD sensor.
Yeah, I mean, I would say that once you have the information about the schedule solution, you could use that to then grab additional reports from STK to give you the other information you need to drive your other operations, if that makes sense, all via connect command. And so we talked today, I think we're about at the end of our time, we talked today about STK Scheduler and STK, and I'll say about STK, we're not limited, any modules from STK can be used to drive things in STK Scheduler, so there's no limits there. You can learn more at agi.com training, and there's some information here about how to contact AGI support and information about future webinars, or If you have specific questions about STK Scheduler, you can contact Orbit Logic directly.
And there's a really nice tutorial that comes with STK Scheduler that goes through a lot of the basic features and how you go through things, its integration with STK, how you set up tasks and resources, the whole ops concept. And then there's a lot of questions about the slides being available for later viewing. I think AGI posts those.
Yeah, we'll be sending that out to all the registrants and attendees. So make sure to keep an eye out for that in an email. And you can also check it out on our YouTube page.
So there's two other questions if we have just a couple more seconds.
Yeah.
Can Scheduler be run even if STK is not being used to generate its input? Yes, it still uses an STK license, but it can rerun it as a standalone module. And is Scheduler UI view only, or can it be used to enter a change and rerun a schedule? And I think they're talking about the Scheduler Online viewer. Currently, it is view only, and that's been what people have asked us for, but we are working for.
We've delivered custom solutions that include, the ability to enter information, rerun schedules all via web control, and we are working towards a generic product for that. But so far, the interest from customers has been for specific program implementations of the web viewer to be specific to their mission, the kinds of tasks that they want their operators understand, and things like that. So, and I think that's it, unless AGI.
Yeah.
Anything else to wrap up?
Thank you so much to Ella and Alex for helping present and with the questions, and thank you to the audience for joining. If we didn't get to any of those questions, we will be answering those individually after we sign off. And make sure to sign up for our next webinar on February 6th on Voyager, a simplified proximity operations tool. Again, we will be sending the link out for our YouTube page, and so be sure to look out for that. Thank you guys so much. We'll see you next time.